You have the white belt in the first station and then the cross belt in the second station. Not all of these parts will require that, but as you see, some of the parts have quite a bit of dross. Surprisingly, the 16 gauge has dross, maybe because it is PVC coated on the other side, and we will run both sides. Then we also have a part that has some engravings on it, and I will demonstrate how that turns out. As I said, we have some parts that have no dross, and then we have others, like this one, that has the typical weld splash on the surface and also some dross around the smaller holes. We have some 3/8 inch parts where we only need the cross belts because they cut really clean, and the same with some 1/4 inch, which comes very clean. So we will run all these, and we also have some very small parts, as we can see here. I'll put my hand down so that you have that relative in size. The machine control is very simple. You set up for thickness. I will start with the thicker parts first. We will go to a thickness of 9.6 millimeter. There we are, give or take, maybe a little harder, but you see the controls on the bottom. We have the adjustment for thickness. We have conveyor belt on off, which we can turn off here. We can pick a speed. We will pick a slow speed because we are only going to do about 50 inches a minute, because we are only going to do the cross belts, and then we are going to turn the cross belts on at full speed. And we have the adjustment for the cross belts up here. We are going to go in a little bit deeper at 47.1. So here we go first with this round, and at the same time with this oval. This oval has a little bit, you can see it here, there, but you'll be able to take that off very easily. Now, this machine is longer than the DM1100Z, so it will take a little bit longer for the parts to come out the back. It's about 2 meters long at 1 meter per minute of belt speed. It will take about 1.5 minutes for the parts to come to the end of the take conveyor belt. 2 minutes. And you see the edge roll. Single pass, and the same. So, then immediately also, you know how we do this. We're going to take this pen. I'm cameraman, writer, and operator at the same time. So this was 1.2 meter per minute cross belt only. 1.2 meter per minute cross belt only. Now we will do the reverse side for those. So we will do a little bit something. What we will do here is we will first speed the conveyor up a lot in order to get them further in, and then before they come underneath the cross belt, we're going to slow it down to 0.9 meters per minute, which is about 3 feet per minute. nice round, especially on this kidney-shaped part. Again, 0.9 meter per minute. dB only. 0.9 meters per minute. dB only. Well, good then. Now we're moving on to the 6mm part. This part looks to me like it has been deburred actually by hand before. So this is not going to require a lot. All we're going to do here is we are going to reduce our material thickness to the correct dimension. And because we are brushing only, it doesn't need to be super precise. It can be a little bit lower. So you want to place this part on the belt so that it is open in all directions, so the belt can hit it very well. And this one has this little piece of sludge on the end, and you will see if you place it. So we are placing it sideways. And again, I will speed up the belt for a moment, and then go way down 0.9 meters thickness. Very nice and clean contour. So, the big question is, did it take the little piece of dross? I will move on to the table here. I will throw this part on already. Let that go. So here now, you see that we have a little bit left because it had that piece of dross, and that's where the white belt sander could come in very handy. For a lot of people this is very acceptable, but I, for now, will mark this. This was the piece of dross. 0.9 meters per minute. Dross belt only. So, on the other side, because it doesn't have dross, we are going to run a little bit faster again at 1.2 meter per minute. And you can right away here. You see the edge quality, very nice. 1.2 meter per minute. So now we have a whole bunch of small parts which we will run next because I don't have any dross. Then all the rest of it, these parts have dross. But these three here do not. So we start at 4.6, then we put that on. We just adjust the thickness down to 4.6. A little bit higher. We'll go a little bit higher here, and what we'll do is we'll reduce the speed of our process. You can hear it in the sound, and we will keep the processing speed the way it is. And then we will see whether that part we fully expect it to hold, but it's always good to make a test. If for whatever reason smaller parts do not hold, you want to clean a crack on your conveyor belt with a little bit of a more potent cleaner. Usually we clean the conveyor belt with 409 or something like that, but you could also clean it with alcohol, or if you want to make it really sticky, you could clean it with acetone. Acetone, of course, removes some of the volatiles from the rubber, so you may have an issue with the rubber hardening over time if you do it all the time. If you do it just every once in a while, it will not make a difference. Comes the part. Very nice edge. Good finish. So that was at a reduced speed on the cross belt, and we will do the same thing for the other side. I'm going to look for a nice clean spot here on that belt. Get that on there. And for a moment we're going to accelerate the belt. And then back down. Back to 1.2 meter per minute. And like I say, we are running at about 70% on the cross belt speed. Beautiful edge. So, and I know this is a little time intensive, but we need to do it for each thickness at the same time. First we're going to do the thickness. To about 3.2. You notice that I put the part already on. If I'm coming from the top down, I can do that. From the bottom up, that's ill-advised. And I want to go a little bit over. And yeah, now I've given the part already time to move. I'll give it a quick tweak and come right back down. The thinner the parts are, the better they will hold. That's the rule. I think it is a good rule. I don't know if you can generally always apply it. Right now you won't see anything because the pressure rolls are almost from the seat. And also the static strip that you see in the back to take the static out of the parts so they get shocked when they come out is preventing heat from leaking. Again, you see very nice edge. At 1.2 meters per minute, 4 feet a minute, basically. Same thing again. Give it a quick breathe. And we come right back down. Part already. I am not sure that I hit that with 1.2 all the way, so I'm going to mark that as could be faster. I'm going to mark these parts a little bit later so that we keep on going here, and then we are going to put the 2.5 on. So you see how quick it is to go from one material dimension to the next one. Would not be a problem for that. Now we're going to put the belts a little bit higher so that we are out of the conveyor. running. This was 1.2 meter per minute. 1.2 meter per minute. Because the part is small, I'll just write cross belt. And this was cross belt, but it could have been anywhere between 5 meters per minute to 1.2 meters per minute. And this side was 1.2 meters per minute. I don't want to rerun it so that you have the original results. Rotate a little bit, but we have a very nice bed. All complete. Temperature in the part, you see the white line. The white line is indicative of the radius that we remove. 1.2 meter per minute. CB. Same thing here. Slower gets you more radius, of course, faster gets you less. So now we are getting into parts that have quite a bit of dross, like this one. Here it is important, before you put the part onto the belt, that you set your material thickness. And you need to set it pretty good. Better to go a little bit higher than a little bit too low. So, but the part is larger, so we can go full speed for the cross belt. We have a good depth in the cross. And of course, we do need to turn on the white belt. For the sound of the white belt grinding, there it is. That's finished there. And then the part progresses. And of course, we do need to turn on the white belt. Now you have clearly more temperature in the part, and you also, I think you made a little bit different cut here on this corner, where you made an angle actually. So on the back side, you would not need the white belt then. So we're going to keep that for later, plus I want to demonstrate something you, because now in this surface you see a little bit of a process. So this was 2 meters per minute wide belt plus cross belt. Now, with this part we are going to do something different. We're going to set the thickness to 4.6, but we are turning the cross belt off, and we are only running the white belt, and we are running at 8 meters per minute, but we run at a very nice pressure. So you see this part going in exactly lengthwise. You're going to run it very much lengthwise. And then we are going to take this part. You see the finish on it. This part now has very sharp edges. You cut yourself, but it has a very nice grain. In order not to put a cross edge into it, we are now going to turn the white belt off. It will retract by itself. We are going to turn the cross belts back on. We need to put them in harm's way. It means we're going to bring them down to the 47 where we were sitting before. And we are now going to put this part on exactly parallel. And of course, we are going to run it nice and slow at our comfortable 1.2 meter per minute. Rotated, it shifted a little bit. It didn't hold the way I wanted it. Now we still see a cross edge. So what I will do with this part is I will try this again, but I will run it a little bit lighter underneath the cross brushes. And I will orient it this way. So again, we'll turn these off. We'll turn this on. We'll take these out of the way, and we will go to a higher speed. Turn the brushes on, turn them down slightly, and we will not run them so hard. We run them a little bit lighter. Out a little bit in my report. So now we're running the cross belt and white belt in combination against an angle. And that is this result. You get more of an edge rounding because the part is at an angle, of course, right? And you can run it heavier and you can run it faster. So this was a part here in comparison. This is the part, 2 passes. The white belt and the cross belt is rotating it in between 2 different speeds, right? And this is the part at white belt plus cross belt 1/2. And this was at 8 meters per minute to make the grain nice and straight, and this was at 2 meters per minute. I'm not going to write on the other side so that you can see the surface. And I'm not going to write on the other side here. I ran that the second time already. So now, and we're going to do the same for this part. You see the dross here. All we are going to do is we are going to bring our material thickness down to where we need to be. About 2.5. Okay. And we are going to bring our speed a little bit down. More edge rounding. And here we go at an angle. I had to check for myself that I have everything turned on still. And there we go. Very nice result. All the dross is done. Okay, all the dross is done. I could have ground a little bit harder here on the inside console. If you see that, I would have had to set my white belt a little bit harder. We have 180 grit on the white belt here. If you went to a coarser paper, you would probably eliminate that. So that is white belt plus cross belt. That was actually 2 paths. Yeah, correct. 1 light, 1 medium, and the grit was, as I said, P180. Okay. Of these two 16 gauge parts, we're going to do this one first. That has quite a bit of drop. So we are going to set the machine for the correct thickness. Now I get a warning sign because I'm a little bit too deep in with my brushes, so I'm going to raise those out of the way. A little bit in is fine. So we are a little bit into the conveyor belt, and we are going to run this at a diagonal at 2 meters per minute. So now we have these 2 parts left from the other side, one with a engraving and one just with the laser foil. So what we need to do is, first thing we need to do is we need to turn the white belt on. We won't need that. So we're just going to keep the cross belt. We are actually even now with the thing, we have it set pretty light at 48.5, right? So it's out of the way. And we are running at 2 meters per minute. We are going to speed that up a little bit to 2.7 meters. so that we are lighter, less interaction with the you see, this comes to PVC and it takes the edge, but it does not take the PVC. Here on the small part, where we have a small partner because of the heat of the laser, it disattaches the PVC sometimes, so you're removing more, and your engraving is perfectly fine and almost untouched. Actually, if you had an engraving without the PVC coating over it, you would be enhancing it, you would bring it out. So the big part had already run from that side. This one doesn't have any burr, so we are going to do exactly the same thing. We're just going to run it through the cross belt. We're going to speed the belt up a little bit. Well, so this concludes our test for you. Again, thank you very much for sending the parts, and I hope this sheds some light on the process that we used here today. It's really not all that complicated. Think about it. Combination machine is always a great tool, gives you good flexibility. Thank you very much, and I'll be sending those parts back to you.